Good morning and happy Friday. It's Friday. Good morning. Get going. Let's get going. I think we're ready, mostly. I probably forgot something. I just don't know what it is because it's forgotten. Just that. There we go. Good morning. How are you? Fourth wall moment. I forgot to actually go to Twitch on my phone. I do that occasionally. I have Twitch over there just in case other things disconnect. Press and hold, and then poof, you're on your own stream if the phone's going to do it. Anyhow, it's having a moment. Yeah, we'll wait. There we go. Okay, so we're just going to do some like really rough cuts into processing connections. Got a little stream logger going up here. We're using the log crate. It's printing out using Alto Logger. So we're going to process the handshake, and then we'll have some other loop here. That we're actually doing something with the stream. But first, we got to get past the handshake. All right. And the handshake does a couple of things. I don't know what we're going to get out of it at the moment. Let's just get it working. We might need to keep the time offset from this. So the first thing that we do is record kind of now, right, which is when the stream first starts. We record now because that's when we get our first packet. Uh, Technically, it should be when we receive the first packet, which is kind of there. So here's the time, et cetera, et cetera. I mean, this stuff is just, it's going to happen so close together. As soon as we've read the U8, but if some client is sending these packets individually, then we would get the U8, which is the version, and then we would get the time. So we could record it there. I think it's more accurate to say, hey, we've gotten the entire packet. So this is a C1 packet. All right, and once we have that, we need to send S0 and S1. The server packet's going to the client. Same thing, we're going to be sending a U8 for the version. This is not correct. All right, then we're going to send the time, which for us, our stream is going to be, we're not sending data to the client, so we're going to send a time of 0. And the second part of S1 is actually a U32 that's just set to 0. Right? Because S1 and C1 are the same, and then S2 and C2 are basically the same format, which are basically cousins of the first pair, with the time and S and the 0 actually filled in with something else. So they'll get the time, and 0 will also be a time. This random bytes, it must have been useful way back in the day. I doubt that it's still useful, but we're going to fill the data with random data, fill the payload with random data like they say to in the spec. Say you can fill it with zeros or quasi-random, which is why we're using fast rand. We do not need um, cryptographically secure random for this. All right, we'll get back to that. before we get down to S2, etc., actually, we can just comment out the one line here. Let's look at this. No method name input to U8 found for type parameter W in the current scope. Okay. What is W? W is an async write. The reader has read. Do these have write? We're just keeping it just simple for now. All right, if we wanted to buffer this up, perhaps in S1 here and then send it all at the same time, we could do that. Oh, that expects to be OX03. All right, now as part of the spec, we have to send a couple of values that we had before, but I don't remember which order they're in. Here we go. I think this is C2 and S2, yes. So it's time, time, and then we echo their random back to them. And here you can see this little graph on the right. We receive C0, C1, we send S0 and S1, then we receive C2, and we send S2, which I don't think that's, this one's slightly different. Yeah, and then you can send S2 right away. Basically, you receive C1, send S2, and then eventually you receive C2. So you're not really supposed to wait for C2 before you send S2. Why am I implementing the server? Oh, don't ask silly questions. So I'm kidding, I'm kidding. That's a great question. I am implementing this as a little bit of a buffer. Well, because, hold on, this, it's having a moment. I'm trying to load something on my phone so I can show you. Ah, now down here, the very bottom, oh, where's OBS? Oh, I can kind of see it over there. Down at the very bottom, um, you have latency and I don't know, as a SNR ratio. And if you look at the SNR ratio, my internet connection kind of drops out occasionally. So what I'm trying to do is create a little bit of an RTMP server that can buffer and proxy data to a server that's actually closer to Twitch and send it on from there. So I'm going to be running a local RTMP server that takes the data, sends it to something on the other side of my internet connection, closer to Twitch, and then that one will then feed Twitch the RTMP data, creating a low latency buffering proxy. And that should iron out some of these issues here. Because here, if I pull this up, I'll bring this on screen once I know it's safe. Yeah. So this is the stream thus far this morning. You can see we get these little drops, unstable every now and then. And you can see that sometimes we get these other just spikes that plummet, but it's got a little buffer built in on Twitch's side. It's just not quite enough. There will be a little bit more delay, a little bit more, but hopefully not as much as there is now. So that's the goal. Because when we get these delays, sometimes it causes issues for viewers. And also, when I export these to YouTube, it affects. I mean, heck, it's writing more Rust code. I love writing Rust. What I was curious about though, and I didn't see something with this. Maybe somebody out there knows. Where is it? I know that we could use Saturday for different kinds of things, right? Exporting, like serializing to different formats. Um, but if I did want to have, let's say, an S1 type, right, which I've played with on stream maybe yesterday, um, it's going to have three things. It's going to have S1, 0, and then random data. But then in order to write that out, we have to get that into some format that this writer can understand, which is really just a string of U8s and has to be in the right format. Now, we could write our own serializers for this using Saturday, which would work. Um, but it seems like quite a bit of overhead for, I don't know, it just seems like we're going to be writing more than, how many lines is this? 15 lines of code for doing that. Like it's almost, maybe we should just have, a simple function for this and not a serializer. I mean, it is a serializer, let's face it, but I would love it if there was like a safe struct to byte array. Oh, the wrapper times to enable optimized handling of that. No, no, it's not that. Okay, what about this one? Saturday adapter for controlling representation of bytes. Guess we could also use those other formats for this. What is it? What is it? Okay, sorry, we're playing the Surprise Me station. I I like this kind of music sometimes. I'm not gonna thumbs down it, but right now it's not that time. It's like Friday morning. It's very like peppy, isn't it? All right. Yeah, see, this isn't it. And if we go to Saturday.rs, can we search in here? Edit. Hmm. All right. So they list all of these different kind of data formats. No, the base on that's too choppy. It's not like a smooth, it's like a rough base. Certain sounds I just don't like. All right, now using derive, custom serialization, implementing these, writing a data format, implementing a serializer. Yeah, we don't need that. Container attributes, here we go. Rename all, no, tag. Looking for like a serialized with. Isn't default. Huh. All right. Well, I want to just make progress and get it serializing. I'll probably come back to this because that's gonna bug me. I want to have a cleaner way to do this. And while this is simple, it's just going to be a long function. All right, but let's get it working first. Get it working right. Get it, get it working right. Get it working. Well, what is the progression? It's basically get something working. Get something working with, I don't know, like refactoring it, cleaning it up, right? Followed by optimization. Optimize last. And I think that actually optimization is more performance and not dry, like drying the code up. Oh, you can't hear any music. Oh, I see. There it is. All right. So in this case, we're going to send S2, and S2 is, let's come back over here. We were on page 9 before. We have 2 times, and then the random bytes from before. Must contain the timestamp sent by the peer in C1, because we're sending S2. So we need that timestamp. What did we save it as? C1 time. So we're going to write out C1 time. Followed by, this one must contain the timestamp at which the previous packet, C1 and S1, sent by the peer was read. So this is the C1 time. We'll say that it was read then. And That's going to be a delta from the start. Let time start be equal to instant now, in which case this isn't that, this is time start dot elapsed. And we want milliseconds. Okay, we'll take that C1 received and send it out next. Then we must also send the random data field sent by the peer in S1 or C2, for C2 or S2 for C1. Or S2 for C1. Okay. So basically we send them the data that they sent us. Oh, what is this? Oh, that's a U128. Um, yeah, that's not going to work. As millis dot as U32. It should be short enough. That's a slice. Oh, wait. Why does it want to turn it into something of type U size? C1 data is a U size? Oh, that's how many bytes were read. I shadowed the variable. We do not need that. Because if it can't read exactly, then the try operator will toss the error and bubble it back up. There we go. Now it should no longer be a U size because we're not shadowing it. All right, so that's S2. But now we need to wait for the C2 and verify that, well, that we got our data back. And we should also be able to tell the timestamp difference in the client. So now we are going to receive the C2. And the C2 should look kind of like the packet that we just sent out. So it'll have a time difference for us. That'll be nice. It'll have the random data. We could verify that it is the same thing. What else? It's interesting that it's like you don't even need the rest of this. Sorry, I was just thinking that like why are we sending the C1 time back? Is it so that the client can verify that the time is the same? Or is it just so that the client doesn't have to be stateful? I mean, it could be that. I don't think they actually talk about that. Yeah, I don't see it in there. All right, we'll treat it as more validation, but receive C2. Oh, we got our capitalization different here. Look at that. We're using S0. All right, fine. We'll use lowercase c there. Oh, all right. First, we get the time. U32. Actually, two of those. Data, which we don't have yet. For these, I'm actually using a little bit of unsafe code because I don't really care for. Maybe it's the C program me that's starting to get a little bit more comfortable with Rust. Tommy Luco, good morning. Good morning. I guess we could use the C1 data because it's not used anymore. Why allocate again? Because we don't use that after sending it back in S2. So we could just use that buffer again. Let's do that. Do we call it C1, C2 data? Be a little bit more descriptive. Hmm. See, this is a premature optimization that you're not supposed to do. You should just take the allocation, come back, look at it, refactor it. Because there's probably a bug in here. Oh, read exact. Okay. It's likely that we have to clear the buffer or something like Because we already read into it, which means that the right head is at the very end of it. Let's bump up the font on that so it's easier to see on screen. What are my weekend plans? Um, Gotta take out the trash. Yeah, we can do that. Probably do some welding. Got a buddy that's coming over. We're gonna do some welding. Um, Start at the next D&D campaign. That'll probably be on Sunday. Oh, and I trimmed the stash. Just you've never played D&D in your whole life. Uh, it's fun. It's like it's exercise in imagination. It's better than sitting and like watching a show. Um, I am a fledgling game master, though. I'm very new at it. Usually, other people are being the dungeon master. I think all Clear should be doing is moving the right head back to the front and truncate 0. Yeah, that's calling truncate. Shortens the buffer, keeping the first length bytes and dropping the rest. I see split off. Actually, splits the bytes. Okay, so we're just going to use clear. Oh, you know what? Oh, look at that. Forgot to get the chat going today. Now I'll see your chats earlier. All right. So we have the C2 elapsed, C2 time and elapsed. That C2 time should be the S1 time that we sent. Row because it started at 0. All right, and let's do some validation. C2 elapsed. All right. It's interesting with the elapsed time. You could probably get some sort of glimpse into the delay between the client and the server in each direction with this, because you both get a bit of information here. That I'm not sure if that's all that useful because being the first couple packets in a buffer, the networks are going to optimize and adjust for you. So I don't know how useful knowing those values are, just because the networks are much more dynamic than they had been in the past. All right, let's validate. If C2 time is not equal to 0, which is return error. We're going to say that this is a standard IO error. Oh my goodness, you're not really into RPGs or tabletop gaming? I've literally got like 40 tabletop games sitting right over here. Betrayal at House on the Hill, lovely game. Small World, fun. Carcassonne, Settlers of Catan, of course. Um, Goodness, all sorts of other games. Just this is a programmer's game. If you've ever wanted it like a programmer's game, um, super fun. It's like a race of of robots that you send commands to and have to hope that the other players and you don't crash and laser each other and stuff like that. It's a lot of fun. Then there's things that you might run into on the board itself. Smashers, chompers, lasers, whatever. Error kind. Now, is it this one? Yeah, the parameters were valid, however, the error is caused by malformed input data. Yeah, we're gonna go with this one. And the message C2 time must be. Prefer single player games? Yeah, that's cool. That's cool. There's nothing wrong with that. I know a lot of people that like single player games. I also like playing single player games. It just depends on kind of the situation. I also like card games, but not like poker. More like hearts, spades, um, canasta. Yeah. Oh, as actually. So what sort of single player games do you like? Professional poker for 3 years. That seems cool. Poker is for me a challenge because it's it, it's much more about. I mean, you gotta know the numbers, right? You gotta know the numbers. Um, but the psychological aspects of it, like you have to be good with that stuff. Yeah, math meets psychology. Kind of reminds me of like boxing meets chess. All right, now in this case, colon 04x, no, hash 4x. Now let's use the same value that we used for S0. Where's our time? There we go. Oh, what's the error type on this? IO error. That's an IO error. Expected function. Oh, error new. Good morning, Bear Duda. No worries. No worries, Tommy. All right, C2 elapsed. I think it's just interesting. I don't know what to put out there. uh, marriage. True love. All right, that's funny. All right. COVID made him rich. What? Wow. Wow. All right, now let's validate C2. If that's not exactly equal to C1, what do we call it? Buffer? No, S2. This one, S1 data. If C2 data is not equal to S1 data, oh wait, I mean, made the comment too. Oh, I see. You had people sitting at home gaming, tossing money at them. Gotcha. Gotcha. So online poker playing, that's different than like in-person poker playing, right? Because like the psychology of it is different. You don't actually see the people. You don't see their hands. You don't see their eyes. You don't see their tells. S1 time. We're not going to print that out. You see how they play, how fast they fold, check, raise. Hmm, gotcha. Still gives you tells. It, I mean, it's quite a bit less. So what are we going to do with the lapse time? At this point, it's a curiosity to me, so I'm going to log it. Oh, I see. And you have to play higher volumes. Whoa, 10 to 15 tables at the same time? You know what I need in this? I need the address because I want to know which client it is. So we are going to pass the address in. Oh, every mistake costs you money. Yeah. Hmm. Still waking up. All right. Oh, that's right. We're adding the address. Just gonna add those. What else? One more. You start like with $25 and build it up to some decent sized bankroll, like 10K or so. Oh, I don't gamble. I'm not good at gambling. I grew up not far from Vegas, like a couple hour drive from Vegas, Orange County area. So like the rule was you decided how much you were going to lose before you left, and you just had fun. Just had fun. And if you happen to be up and you wanted to stop, then you stopped. Yes, good morning, 715209. How are you? All right, this should get the first section. Let's try this out. I was looking at Tokyo stuff. Cargo. Run. What are we going to run? Dash dash bin. Stitch server. Underscore. Thank you. Years ago, we had $26 in your wallet. I told her let's try not to use the ATM. So you put $26 on a machine roulette, got a couple of times really lucky, and you had about 200. From there, you managed to gamble and eat 3 days. Wow. Yeah. See, no, ours is mine is exactly the opposite, right? You go with like, $1,000 in your wallet. You eat, you pay other people to play with you, and then you leave. You're done. You drink, yeah. Needless to say, I don't go to Vegas. Not often. It's been a long, long time. All right. At one point in time, I wrote basically a debt management system for, was it Park Place Entertainment? Long time ago. Long, long time ago. See, I'm not even using this S1. It's like there's no point. Not yet, anyways. I'm just gonna make it compile. You're not a tournament player. Hmm. Oh, that's not used for living slash gambling otherwise. Gotcha. That makes sense. All right, I think we're gonna try running this again. Now I need something to stream to this. I need to start up like a second instance of OBS. Here, we're gonna open OBS way over here. Streaming with at the moment. Stream. We're not gonna do Twitch. We're going to do custom server RTMP : // 27001. colon 1935. Stream key, delete it. So we do not need that. We'll hit OK. And we're just going to stream like this simple thing here. Okay, but what we're interested in is this. So let's hit start streaming. Failed to connect server. That was really anticlimactic. All right. Stream RTMP colon slash 127.0.0.1 1935. I thought it was is it 1935, 1925? 1935. They're super swingy. In 2018, your friend was about 200,000 down over the whole year. Wow. Wow. Netcat. Looks like it. Okay. Huh. Nothing. Oh, we didn't run this with logging. Let's log trace. There we go. Okay, good. Let's try again. That's what found that. Morning, Ergo. Good morning. All right, so we got a new connection. Closed that. C0 expects 0 to be 03. Does that even make sense? Expect 0 to be not 0? Well, that's different. Why would they pass something that's not 0? Did we do this right? Okay, we read the U8, right? It passed that. We record how long things were to elapse. We read the next 32 bits, 32 bits. Hold on a sec. Be right back. Give me like 2 minutes, okay? 2 minutes. And we're back. Okay. My wife got hurt yesterday. Can't lift stuff. So, C0 expects. Also, let's fire up Wireshark. Close. Stop. Loop back. Oh, we're just okay. Let's fix the spelling mistake. 0. All right. But also, we should now have Wireshark, Handshake, C0, 0 plus C1. The handshake data is just a whole bunch of random data. At the time, and then 4 zeros. Okay, so my setup is wrong. Handshake, we get that. Oh, we didn't read the time. We're supposed to read C1.time. I moved it. Ah, actually, I see the bug now. Okay, so I moved the wrong line down. It should have been this one, not that one. See? All right. Again. Yeah, let's clear this. Yeah, continue without saving. I can't think of a time when using Wireshark, like continue without saving actually saved me. Oh, look at that. Could not access a specified channel or stream key. Please double check your stream key. Lovely. Okay, so we got that looks good. Handshake data. Yeah, our time and that are the same. Oh, C2.data must be the same as S1.data. Uh-oh. So this buffer we last used for C2's data. So we generate this, we send it out. Thinking about the YouTube videos you want to make? Nice. All right, I'm just going to try to eyeball some of this. So S0 plus S1 plus S2. Interesting that we send C2. Okay, so C2 data, that's here. We have 8 bytes, all zeros, because, oh, because the time between them was less than a millisecond, and my start time was 0. Okay. But here we have, can I open this somewhere else? Yes, perfect. Put that over there, bring this over here. Now S2, the random data that we sent, so S1, I think is this one. And it's saying that S1 should have been equal to this. 1AF2E, 1AF2E. That looks like it's the same data. All right, so it must be my problem then. I mean, for index in, am I sending the data to myself to capture it? Yes, yes. Here in this instance, I am. Let's see, we're going to use buffer. We could just zip them together. And we want to enumerate. So in this case, we get index like so, I think. If they're not equal, A not equal to B, this is more debugging stuff. So we're just going to debug this out, dbg. Did this not run? Where's our panic? It's because this isn't doing equality. This is doing an identity check, isn't it? Yeah, it's like we don't need either of those. Anyhow, so what does it type on? This is bytes mute. That's bytes mute. Okay. It's partially equal. As slice. So if the two slices are equal, all right, let's check this in a different way. Because for whatever reason, they're equal but not equal. And I'm guessing that's because the slices aren't equal, then what's our as slice? It's not there. Hmm. Where are you? Into iter, from iter. Yeah, no. Hold on, I'm gonna look at the partially equal again. 4 bytes mute. Self as slice. Where did they get as slice on this? Here. Ah, from raw parts. We're going to change that to see if they're equal. Run it again. I want to verify that it is going in there and that everything is in there and that it's doing all of the indexes. There's something slightly off. Okay, it's not going in there. What? C2 data must be the same as S1 data. It's right there. That means that there is no data. Buffer has nothing. It's either buffer or because we cleared it. That's what it is. We cleared it and didn't set the size again. Let's just read exact into there. The whole thing. Okay, that clear was the wrong thing to do. That's going to be it. Get it working. Step 1. Start streaming. Look at that. Yep, we made it all the way to the end that time. Okay, we found that error. Let's get rid of the debugging. There we go. Okay, after that, oh, look at that spider. I think I've got like 3 little buddies hanging out with me today. But my other buddy, oh, I might have to go move a goat for a moment. All right, I'm going to come back over here. I have to move a goat, like literally move a goat. What is that? Oh, the spider. All right, I'm gonna move a goat. I'll be back in 6. And we're back. All right. Well, that's probably a good point to get the first piece committed. Okay. Now for the next part. So the handshake works. I'm not sure what we're going to want back from the handshake. Now for the stream bits. Now the Wikipedia page is easier reading than the rest. Um, Actually, I'm curious what happened in Wireshark. Handshake, handshake, handshake. Set chunk size. Interesting. RTMP header. Hmm. And I don't think we're going to go too far into the body here. We're going to be looking at the RTMP header for these. So I think we need the timestamp on a lot of this. Chantilly cake. Oh, welcome, Raiders. Good morning. How are you, Brooke? How are you doing? Happy Friday. It is Friday. Friday. Yes. How's the server going? We can do the handshake. So we got the little handshake going. Um, that's working pretty well. We're going to go into the next stage, which is three packets. The next one is this here. So we're going to look at what it takes to get past this one. We're just going to go through Wireshark, just one after the next, getting these things done. It's kind of like, I don't know, feature-driven development, which I think what this is going to mean here is we just need to be able to look at the RTMP header. Because the first incarnation of this, for me, is just being able to send this and buffer it um, through a series of machines. Kind of like a proxy, I guess. A delaying proxy. Yeah, this looks like it should work. It's kind of a 2.5D environment thing. We could support about 5,000 users per machine. It's pretty good. It's pretty good. Um, so across all the machines, I think we had like 20 to 30,000 players concurrent, maybe more at the beginning. It was a lot of fun. I think a lot of people miss out on how important it is to have back pressure on a system, which is why I spent so much time with that for Stream Multiplexer, which I think Stream Multiplexer has to change because Tokyo has changed. Then I've actually played around a lot with Erlang and creating servers in Erlang, and it scales so beautifully. So nice. Time issues mode, and that frees up concurrency really, really nicely. Let's say clone, but you could like COW, COW them, which is what Erlang does. Erlang's just a bunch of cows inside. Clone on writes. So y'all got weekend plans? What are you planning to do? Gonna do some welding myself. Get some welding done, and we're gonna start our next D&D campaign with the kids. So I have to do that. Hiking. Oh, lovely. Nice. Very nice. So I wonder how much of this has to. I'm gonna have to deal with. Hiking sounds cool. Oh, it did it multiple times? Well, let's restart this. Run that again. OBS. Oh, wrong one. Yeah. So chunk size and connect. I don't think I'm going to need to even touch the RTMP bodies. We're going to try to do this just with RTMP headers, because I think it's just the timestamp I need to adjust. And I'm not sure why this timestamp is still 0. There should have been, I mean, maybe it is sub-millisecond. All right. All right. Have a good day at work, Brooke, and enjoy your weekend. Enjoy your weekend. Oops. I'm just going to toss this parse header in there for now. Or maybe we just say header. We have handshake, we have header. You know, we might have body. Who knows? There's a noise. I think my wife's back. So we have header. With header, we will have a reader, which is no, no. This is a little different. It's going to be the same handshake, same thing as this. I don't like this song. I need to remember to thumbs up the ones I like. All right, so an RTMP header. What does an RTMP header look like? Still with a version? Is that the stream ID? Oh, I see. So we have format and that. So we split up a U32, or basically we take the format being that, and then 3 values there. And how does that concur with the actual spec? Okay. Da-da-da. We did the handshake. That's handshake section. Chunking format, basic header, message header, extended timestamp, chunk data. Okay. Basic header, 1 to 3 bytes. Oh, 1 to 3 bytes. Not 1, number 2, number 3. It's from 1 up to 3 bytes. Encodes the chunk stream ID and the chunk type. The chunk type defines the format of the encoded message header. The length depends entirely on the chunk stream ID, which is a variable length field. Tell me more. Hold on, we're going to look at just the basic header for now. We're not even going to look at the chunk stream ID and the chunk type, represented by a format field in the figure below. Chunk type determines the format of the encoded byte, the encoded message header. Chunk basic header field may be 1, 2, or 3 bytes, depending on the chunk stream ID. Streams with IDs being between 3 to that. Interesting that the ID starts at the number 3. Oh, IDs 1, 2, and 0, 1, and 2 are reserved. Value 0 indicates the 2-byte form. And an ID in the range of 64 to 319. The second byte plus 64, let's see, value 1 indicates the 3-byte form and an ID in the range of that. Interesting. However, oh, I see. So they use the first 2 bits to parse that. So the format's 0, which means that they're using 1 byte for this. Hmm. All right, let's write a little handler for this. This is actually something we can toss into the RTMP crate. All right, now I'm going to delete a whole bunch of stuff first because we're not using C1, S1 out of any of this. I think I'm going to just delete this file. Okay. Should we call it chunk, then header? Basic header. And we'll call this like stream ID or something like that. RTMP source lib. No. Basic header. Should that be a directory? I think we want that to be a directory. Now let's just put it in there. Basic header. We can split it up later if we want. All right. Read stream ID. Read stream ID. What should we have at this point? I do not want this crate to be async or to know anything about that. In fact, fast rand is probably too much for this crate. Let's delete that. But it can be 1 to 3 bytes. Do we always read 3 and then see how much it wants? I like headers that have a fixed size. Basic header 1, basic header 2, basic header 3. So we basically need to parse the format. So based on the first byte, which is these 8 bits, we'll inspect the format, then return how large it is, and then they'll pass in that byte again with the remaining, any additional needed pieces. So pub function, let's see, basic header size. Oh, we'll just say size. Data, that's a U8. And we will return, goodness, this could be a U8, but all right, now based on the data, where was it? If Chunk stream ID, okay. ID 0, 1, and 2 are reserved. Am I just missing it? Where does it talk about the chunk type? These 2 bits here, the format. They talk about it there. Do they talk about it up above? I don't see anything. Depending on this chunk stream ID, okay. Ah, it's like they're talking about different things. ID is computed as the second byte plus 64. Okay, I think this here is actually describing this one. Now, so IDs, okay, 0 indicates a 2 byte form. Okay, well, we could use masking here. Because this to me looks like a little Indian value. Is this supposed to be parsed in little Indian format? Where's the high bit? Oh, interesting. This field identifies one of the 4 formats used for the chunk message header. What? One of the 4? All right. Doesn't actually describe it in here. That's okay. All right. Well, we've got a couple things to work with. We've got our Wireshark that's going to help. And in this case, format is 0. Why don't we just return a format? Oh, it'd be format. And then we can return format here. What are the different options for this format? Let's define that. Format's 2 bits. So we can have 4 options. Okay, let's look at the chunk message header section to see. Chunk message header, 4 different formats. Type 0, They just call them type 0, type 1, type 2, and type 3. Okay. Type 0 chunk headers are 11 bytes long. This type must be used at the start of the chunk stream. Huh. And whatever the stream timestamp goes, and whenever it goes backwards, because of a backwards seek, I see. This makes sense. What is this describing? This is just the stream ID, right? And in our case, the stream ID is 3. Oh, actually, it describes this is big Indian network byte order. Okay, and well, let's just fill it in as we get. Type 0, 1, 2, 3. So based on that, we will determine what the byte is. I have to do TO to get that one. All right. What bothers me about this is that something needs to know how to read the bytes off the wire. But hopefully they'll just do that the right way. So we want to mask just the high bytes. What is that going to be? Calculator clear. We want these two. 192 in hex C0. OX C0. So first option is the value 0. Then we have OX40, OX80. Oh, I see. And finally, OXC0. Yes. Okay. Now, what is the type? How do we describe this type? Do they have an example? All right. So this is going to be described here. Type 0, 1, 2, and 3. All we know is that type 0 is if it's type 0. All right. We do not know if these are correct. I'm going to just have it panic because once we get past type 0, then we should eventually hit something in the stream. It'll blow up. We'll look at Wireshark and say like, oh, That's what they meant. Because I do not see a description between the types and the versions. I imagine 0, like when this bit gets flipped, that's going to be 1. That's my guess. So I think we have it in the right order. Type 0, type 1, and 2. But I'm going to leave it like that just to verify. Because, I don't know, kind of belt and suspenders approach. All right, so that's a format. Chunk basic header field, maybe 1, 2, or 3 bytes, depending on the stream ID. Protocol supports up to 65.597 with stream IDs 3 to that. 65599. Oh, I see. So if you get the first byte, like the last, was it 4 bits here? 6 bits. If those are 0, then you use 2 byte form. Value 1 indicates a 3 byte form. Values in the range of 3 to 63 represent the complete stream ID. Chunk stream ID with value 2 is reserved for low-level protocol control messages. Okay. One is how many bytes the header, the stream ID, right? Is the stream ID always going to be encoded like this? So you hear message stream ID continued. It might, because if this is always the same, we'll extract that out to its own function. Where do they describe the message stream ID? Common header fields, message length. Stream. We could use something else like like an actual stream, right? We could have something stream ID and have this take a byte stream. Oops. I don't know. I'm gonna look in standard. Is stream so we'd have to do that and then go back into the other one. Is there a way to go back? Read exact by ref. No. What is source? I'm not familiar with this one. Event source. Oh, okay. Backing out of there. Um, Also, this is, yeah, these async read, async write, those are going to leak Tokyo into the other crates. I don't want that. I want to try to avoid that. Well, let's see. From async read, we can basically get into async read ext. No, I don't want to save that. Go away. And async read ext. Can this give me an iterator? So I do not know how many bytes we can read. Read them till the OS submits to your rule. Yes, it is all going according to plan. Oh, interesting. I got the message. There's a peak function? Kind of. Yeah, the problem is I'm trying to put this functionality over inside of a different crate than the server. So this RTMP crate, and I don't want Tokyo over there. I mean, if I just submit and use Tokyo over there, fine. Like that would just work. Um, because then we could just take an async reader, right, and just slowly pull bytes out. It's either that or I create a future. Because async read is pull read. Okay. Yeah. All right. I think we just have to submit. Now, if we go look at the Tokyo features, where's their big list? Here. Feature flags. We're going to want async read ext, which is, I think, IOUtil. SureShack55, good morning. Good morning and happy Friday. Happy Friday. So I think we can get away with just IOUtil. And in this case, we could take a reader. Then we could peek at the first one, determine how many to use, etc., etc. We could even do the same thing with this, where R is async read. I missed that here. This is really format. Hmm. POC restart. Go. Is it peak? Let's peak return. That's for. Now we want to look at async read ext. Yeah, this is just going to be a read, which we don't want. So let's not change that one. We'll have to pass in the first byte. Or we combine these two because that byte is the same. So we do something like let's do parse for basic header. We'll just write basic header : parse. Give it the async reader. This does not need to be public. We'll return format there, but we'll call it in here. The first byte is always the best. All the bytes after that are chasing down the taste of the first. Yes, so true, so true. All right. So the first thing we're going to do is change the return time. We want format followed by U32 in a tuple. Fine. Now after that, we're going to read a U8. This is pub async function, which then turns us into a result with IO errors at the end. That's funny, Shishak. All right, so then based on the first, we'll get the format. I guess import that, sure. What? R cannot be unpinned. Okay, fine. Needs to be mutable. What else? Or that. Now stream ID, we need to match first. As if it's 0. No. I'm going to rename first. First shall become format and ID. Let ID equal to, it's everything up to C0. It's like C0 minus 1. Three F. Oh yes, that does make sense. Okay. All right, so then if ID is 0, because C0 is actually both of the bits. I was saying that wrong before. It's not C0 minus 1. All right, so if it's 0, where's our spec? Here. 0 indicates the 2-byte form. Okay, so 0, we need to pull another byte. So the second byte plus 64. But we return this and say this is the let stream ID equal to that. Yeah. Huh. That should be a, what is it, U32? Sometimes it's nice to be able to put the return type here because these values will end up influencing that. And if you get it wrong, it's nice to be able to enforce it here and point to the one that is providing the wrong value. Say, yes, not covered yet. Now, if we get the value of 1, indicates the 3-byte form and an ID in the range of 64 to that to 65,599, which is the third byte times 256 plus the second byte plus 64. All right, so let's get the second byte, and then we'll get the third byte. Plus 64. Oh, we have to await that. So in this case, we are going to reader.read u8.await times 256. Non-exhaustive still. All right. And now if it's not that, the third byte, okay. Seems informational. So really, if it's anything else, we just use that value. All right. Test module test 0. Just gonna, no, actually what I want to do is give it this sequence here, and then just use that as a test. All right. If I want to copy that, how do I? I mean, it's just this one character. O2. So to get an async reader on that, let format and stream ID. This is equal to parse. We actually need a cursor on this or something. Stream is going to be equal to a vector. Technically, this is a vector of U8s. What types already? Oh, it's implemented on slices. Oh, this is Tokyo test, which means we need the other feature flag. All right, back up to the features. Is it this one? Maybe. Technically, this is incorrect. This should be under like dev dependencies. Yeah, I think it's called dev dependencies. It's not satisfied. Async read is not satisfied. More than enjoyment. Hmm. Oh, but it's not implemented on. Okay, we could use cursor. That's not the right way to do that. Cursor. Oh, maybe it is. Standard IO cursor. Want that one up above it. Okay. Lifetime issues? What do we have? Mutable. Sure. And that's not used. That's not used. Cannot borrow string. Okay. Here we go. Test nearest. Could not find test in Tokyo. Oh, which feature flag does this come in? Is this macros? Yeah, we're going to keep it simple and go with RT. Thank you. Then I don't think that we actually need the other pieces. Okay, that works. We're good there. See, we can actually get rid of like IO util here because I think it'll join these. Anyhow. Okay, now we can actually assert equals format is, this might need to be matches. No, 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 we should be okay. Type 0. And then the stream ID. Assert equals stream ID is equal to 2. All right, that works. What else do we need to be able to parse this? So we should be able to parse that now. Timestamp. What do we have? 3 bytes. Body, 3 bytes. That's body size. Type ID. Okay. So because this is type 0, we have to parse it as type 0. I don't think that, yeah, you typically don't stream with RTMPS to to Twitch because they're expecting it to go out anyways, right? So there's no point in encrypting a public stream. All right, this isn't going to be public yet, but it's going to be there. Parse, I'm going to say format and stream ID. Lovely. That's so awesome. Maybe we just call it format and stream ID. That would be a little better. All right, because we're still in basic header, right? So basic header, format, and stream ID. So I imagine we'll have some sort of thing that's like a pub async function parse, and that'll be like basic header colon colon parse. You'd give it your reader, right? That needs to be unpin. Messing up. Okay. But in this case, we need to return what? This is going to be, let's return a basic header. No, we'll return a result of basic header or size type ID and stream ID. What? Where are there? Oh, there's chunk stream ID and stream ID. Is this consistent with? Types? Message length continues. Okay. Timestamp message length, type ID, and stream ID continued. Okay. Yeah, so that's the same there. Type 1. No, this one's different. Type 2, it's just timestamp delta. That's it. Type 3, no header. Stream ID, message length, and timestamp delta fields are not present. Chunks of this type take values from the preceding chunk. Oh, interesting. Take values from the preceding chunk. So basically, if you have another chunk that had the same headers before, use type 3 and omit the headers. But that's chunk header. I'm afraid we're getting a little bit off track because the basic header is really just these things. All right. Maybe this is parse basic header because it is so simple. Because then we get into chunk header after this. We'll just say parse, basing function. That got renamed. Great. And that should be all of this section here. We just need some more tests for it. What is the byte order for this? All right, let's try it out. Let's go back to server main. Who knows what we're going to do for header? Maybe nothing so far. kind of a to-do. We'll await that. And let's create a stronger type for this. Instead of that tuple, struct, basic header. Just okay. Now that we have that, let's debug that dbg. All right, now we stream to it. Going to restart that. Start streaming. Go. All right, look at that. Basic header, stream ID 2, type 0. Lovely. Fantastic. It's what we were expecting. But what do we want to do with this data? Do we just forward it on? I think we're going to have to put this in some sort of channel, send it to a different process across the network, and then have that other process connecting to Twitch. Let's get a little further. I think we can still make some progress here. All right, so we got that. Now we need the chunk header, which is the next 4 elements here. And there's different versions of that. Going back into basic header, I think basic header is done. It could probably use some love though. Oh, yes, this is basic header now. Oh, and those aren't public. Let's make those public. All right. Now for the next section, which is our chunk header. Chunk basic header 1. Oh, that's the basic header, basic header, basic header. Now let's say message header. Mod, message header, RTMP, source. We're going to return some sort of result for an enum, which is going to be the message header, or an IO result, IO error. I know we could probably use the result in IO. Why am I not doing that? There's one right there, which is essentially exactly what I'm doing. Okay, IO error there. I need IO error like that. But these are going to be the result IO errors. Import, use. Just cleaning those up. Okay, same thing here. All right, then we have a message header. And this is going to be one of three kinds, isn't it? Type 0, type 1, type 2, and type 3. Oh, that should be 2 and 3. Type 3 is strange in that it's just a repeat of the previous one. So we have to remember what the previous one is. All right, what's message header 0? We have a timestamp, message length, message. Okay, so timestamp. It's going to be in milliseconds, 32 bits for milliseconds though. Followed by message length. How many bytes is 16 plus 8, 24 bytes? Yeah, should be fine. Message type ID. CU8. Message stream ID. All right, now how does that differ? Timestamp, message length, and message type ID. No message stream ID. 1, 2, 3 things. Yep. Type 2. Timestamp delta. Okay. And then if we get to type 3 chunks have no message header. Stream ID, the message length, and timestamp delta fields are not present. Now, here they say timestamp delta. Is that there is timestamp delta as well? But here it's timestamp. I see. I missed that. Chunks of this type take values from the preceding chunk for the same chunk stream ID. When a single message is split into chunks, all chunks of the message except the first one should use this type. Refer to example 2, section 5.3.2.2. A stream consisting of messages of exactly all the same size, stream ID, and spacing in time. Then they can skip the header. If the delta between the first message and the second message is the same as the timestamp of the first message, it's the same as the timestamp. Oh, I see. So if you go 0 from the signature and then you go 1, and then you have that delta there. From the handshake to the first one. Wow. They like spared no bytes, no bits even. All right. Common fields here. Uh, 3 is just a funky one, and that it's kind of the same one as before. It's like I want to keep the previous around somewhere. Oops. 0, 1. So I have async read plus unpin there. What are we going to do? We have to switch based on the format. Previous header. Okay. Match format. format, you don't have all the types for format. Hmm. All right, so if it's 3, then we just give the previous one back. That's the easy one. And this section right here is going to be more complicated when we are encoding than decoding. Okay, now let's go back to type 0. Type 0. Parse 0. Just pass reader through. Parse 1. Reader. We need the commas at the back. Parse 2. With commas. Missing OK or some. Oh, that's right. That's right. Okay, we have to unwrap that. Otherwise, these are all okay. All right, now for parse 1. I'll just do that. All right, so for parsing the first type, we need the timestamp, which is 24 bytes. If the timestamp is greater than or equal to 16777215, okay, well, yeah, this field must, wait, oh, I see. This field must be that value, indicating the presence of the extended timestamp field to encode the full 32-bit timestamp. Where is the extended timestamp field? That's delta. Extended timestamp, here we go. The extended timestamp field is used to encode timestamps or timestamp deltas that are greater than that. That in milliseconds is a long time. Why would you ever have a timestamp delta that is greater than that? That's a really long time. This field encodes the complete 32-bit timestamp or timestamp delta. Presence of this field is indicated by setting the timestamp field of a type 0 chunk with a timestamp delta field of types 1 or 2 chunks to that. This field is present in type 3 chunks when the most recent type 0, okay. But where does it exist? I know, we'll that's so funny. I don't see it at all. Where else? Oh, here. Oh, I see. So, the, so if we happen to get FF for the timestamp, then we have to read more bytes at the very end of the timestamp. Extended timestamp, 0 or 4 bytes. Okay, so it's 4 bytes and it's a time. Got it. That means that each of these, let's see, no, this should be okay. Because when the values come back, if we detect that the time is equal to FFFFFF for parse 0, 1, or 2, then we will look for the extended timestamp, read that in, and use it. Okay, that makes sense. Everybody following? Yes? Questions? Class? Bueller? All right, so we did this one over here. Now we're doing this one here. I think, oh yeah, okay. Scroll, base getter, pass there, yada yada. Okay, chunk header. Here, type 0. I need the music louder. There we go. I just increased it for me. It's not like they have like a read 24. See, these are powers of 2. So we need to read a U8, await that, and we shift that by 16, or we just do this 3 times, or we read 32, get the message length off there, take the timestamp from the other ones by shifting it right 8. Okay, let's do it that way. Let's time and the length. I'm going to read a U32 instead. Of message length is going to be equal to time and length bit mask of OXFF. Yeah, that should just be the message length. Now let time equal to time and length. We're going to mask that to actually we want all of these. Here, let's clear this out. All of those minus these. Oh, that's stupid. Yeah, of course. All right, minus those. Okay, we'll take that, then we'll shift it. I don't remember the shifting priority on that, but we dropped the right 8 bytes off. That should give us our time. And that's going to be a time stamp. And technically this is parse 0. All right, what else do we need for this? Oh, message length continues. All right, so we'll read 16. It's like I just want to like do a cast to a C struct. Like, boom, there it is. That's really what I want to do. Read, so many bytes into a buffer and just cast it. Morning, Rimo. Yes, RTMP. RTMP. Read 8 bytes at a time and build the structure out of there. There's so many easier ways to do this. I have basically this structure. I would love to just cast it. Although this is 24 bytes, I mean, you might be able to represent that in Rust this way. See, this is kind of what I'm, yeah, see, transmute blah. Memory layout for Rust is undefined. Yeah, we could say a repr packed. Lose performance and the ability to take references of fields. Okay. Yeah, U8 plus 16. All right. This is a time where it hurts not to have a formal language specification. Asserted serializer is going to be many, many more lines than just reading a byte and shifting it. So I don't want to do that. Would a crate that adds bit fields work? Mm. Yeah, but it's fun. That's true. That's true. All right. I think I don't know. Is there a crate that? Let's see. That's a great question. Uh, Sorry, I've got to read your name. Flavi or Medios? Good morning and happy Friday, Flavi. And Eddie Bear, how are you? I gotta pour some tea. My get a little dry. Bitfields. Bitfield like struct. Ooh. Updated almost 2 years ago. Is this actually used by people? Looks like it. Appears to have no readme. Okay. Bit twiddling is fun. Bit field derive, 22 days ago. Simple bit field. Wow, there's quite a few in here. Sparse bit field. Let's sort by recent downloads. Hmm. Uh, this one still wins. Let's go to documentation on it. Bitfield combines bitfield range and bitfield fields. Maybe the repository. Let's pour that tea. It's my favorite little mug. Oh, they have examples. There's a README right there. Rust. Oh, is it called Rust Bitfield? All right. Get the lid off this last night, but only one has a cap. All right. Oh, look at this. Oh, oh, this is a complete rewrite of the Bitfield crate. Wait, is it called Rust Bitfield? What is it called? Let's look at your cargo. Just Bitfield. Okay, that's fine. Works on the stable version and uses a different syntax with different possibilities. All right. I mean, that looks all right. Struct, IPv4 header, most significant byte 0, U8. Okay, we'll have to figure out what this is. U32. In this example, all the fields are read-only, as underscore. The underscore as setter name signals to skip the setter method. Where's underscore? Oh, I see, here. Hmm. The range at the end, for example, 30, defines a bit range where the information is encoded. All right. So no setters on that. That's fine. We'll probably need those for the other end of this. Examples. Bit positions, sure. Bit field. You give it the name. MSB 0. I wonder what the options are for this. On, I think it'd actually be more useful if RTMP here, where is it, was doing more things that were off the byte. But right now, everything is pretty much byte aligned except for the last section we parsed, the format here. But that's a great idea to use that. I think I'm going to skip it though. We might optimize to that later, but I think we're just going to read 8 and 2, put them together, stuff like that. So we're going to read a U8. Just going to say this is time. That's shifting over 16 plus reader dot read u16. I know. I was trying to avoid the two calls to read and wait there, but WebSocket framing is similar. You didn't need any kind of bit field stuff because only a few bytes have non-byte aligned fields. Yeah. Let me know if I'm doing this wrong. I haven't done this in a long time. That's going to be a U32. What am, oh, this should be an async function, public async function. And this is going to be message header 0. Type 0. All right. Yeah, missing a bunch of stuff. Go ahead and fill that in for me. Thank you. Now, timestamp. All of these, we're just going to have those defined elsewhere. Let that. Try shifting the cast value. There. Okay. Now we're going to read in the message length, which is going to be same thing. No, it's an or. It's an or. Timestamp here. So that's a timestamp, message length, and we need the message type ID. So that one comes next. This is just going to be a U8. Okay. That one goes away. Time message length. Sorry, that should be a timestamp. What? The type is part of the async body function because of this. What is it complaining about? Oh, down here? That's a U32. Let's do the same thing for timestamp 2. There we go. A little cleaner. There's our timestamp. Don't want to do the same thing there. Arguably, this could be like a function read 24, right? Oh, too many of those. Oh, right. And this needs to be an IO result. Mismatched types. Ah, yes. Needs to be a result. What? Parameter type T, found type U32. Oh, I see. We could constrain T here. We could say that T must implement like a, what is it, U32 from U32. And then we could say T from that. I need another paren, don't I? 1, 2, 3. Yes. That seems like it's kind of wasteful. When are we ever going to read 24 bytes and then say, no, 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 we only want 16, or the other way? That's just silly. Get rid of T. It's just a U32. I mean, maybe it's like an I32 or something like that. Mm, Unlikely. Just keep it simple. Yeah. Now this, we don't need that, do we? Because those two are both U32s. We're just going to OR them together. timestamp, message length. All right, now which one's next? Type ID, which I think we have. Message stream ID. That's 24 bits? Or 32. That looks like 32. Sorry, talking to kids. Now, I want to look at the common fields. 4 bytes, okay. Little Indian format. Typically, all messages in the same chunk will be. Oh, wait. Question mark, boom. Yeah, most do store it in big Indian format. I don't know why they would do this in little Indian format. I mean, network byte order is network byte order. You gotta do this concert, but you have to do everything in the contract. If you don't do everything in the contract, then something's gonna go wrong. Right? And they bury in there somewhere that you must have like a bowl of blue M&Ms in the dressing room. And it's a really easy way to check to see if they read over the whole contract when they get there, because there will be a blue bowl of M&Ms. I forget which rock star that was, but there was one rock star would do that. They would put something else in the contract, and if that one little special thing showed up in the dressing room, they knew they were good. Microsoft folks driving the spec. These are Adobe folks. Actually, yeah. Who knows where they were before? Because this is old. That I mean, this is Adobe has a number of internal communication suites, and I think they all kind of influence this, or this influenced them. So I'm not sure. All right, there's our parse zero. Now, I think we had a field that we can toss in there, don't we? There's our Wireshark. Yeah, we're just gonna copy the body. Can I copy as a hex dump? Okay. Test module test parse zero. I don't know, like that's a horrible name. Parse zero. What are we actually parsing here? I don't know. It's like the first test for parse zero. All right, there's our bytes. Oops. Not very many. It's easy to wrap this up. This we need in a cursor. Oh, let stream equals cursor new vec bang that. And the first one we have to give it a type U8. There we go. There's our stream of data. IO cursor. All right, now we pass that to that function, get the data back. Adobe made PDF. Can't expect much sanity coming that way ever since. Because Adobe bought, was it, what was it? The Flash stuff. That was a separate team. That was an external team. Um, like Shockwave. I don't remember the name of the group, the company is what I'm trying to remember. All right, so now we have cursor. Let's toss this up there. You're reading that Adobe has patents related to RTMP? Yes. Yes, they do. Thanks, Raimo. There goes our, oh, we didn't know. Mhm. It's been reverse engineered for a long time. I mean, like there were like was it Red 5 server, etc. Red 5 was an open source version. It's a media server, doing RTMP stuff. Over 1 million Red 5 installs. Yeah. So used by Amazon. Uh-oh. But yeah, I don't think Adobe is enforcing any patents related to RTMP. If they wanted to, that ship has sailed. You get RTMP confused with RTSP? Yeah, real-time streaming protocol and media protocol. All right, we're gonna pass this to parse 0, a mutable reference to this, which means we have to make that mutable dot await dot unwrap. That means this also needs to be async. Tokyo test, async, blah, blah, blah. Let message header. All right, then we can compare and see which variant it is, etc. Assert matches. That's going to match message header. Was it type 0? What is blocking here? No IO error in this IO result. Hmm. What else? This needs to be async. These need to be awaited. Let's kind of just stub out the others. 0, 1, and 2. Cannot borrow. Oh, we forgot to make that mutable in our test. There we go. Run the test, please. Test passed. All right, so that came back as type 0. What else do we want to test in here? Message header 0. Timestamp is 0 in this case. Can it actually do this? Message length. What does it say the message length? 4, I think. Message type ID, that was 1, and stream ID is 0. Okay. Macro invocation exceeds token limit. Or we don't do it that way. Assert equals. Get rid of that. Use this. Oh, it doesn't implement debug. Oh, message header. Let's go fix that. Oh, yes. All of these should be able to do the same thing. Get all the lovely derives on there. Which is funny because not all of these are going to ever be used, but if they end up in the API, they need most of that. All right, now what's going on here? We have this message header. We're going to compare it against another message header. Expected expression. We assign this to a local anyways. Oh, hold on a sec. All right, thank you. Looks like coffee is ready today. There's expected. Okay. Oh, it failed. Look at that. Oh, this is a good test. That's a good test. All right, that's also a perfect place to stop because it gives me something to do later. Let's see. Ooh, null pointer. We're gonna raid null pointer. But it looks like to me that we're parsing these in the wrong order. Either that or something didn't. It's like shifted by a byte or something. Yeah, maybe it's out of order. I don't know. I'll have to double check. But at least we have a test in there. I'll verify it. Offset by 24 bits? Oh, that could be. All right, y'all. I got to run. So until next time, bye bye.